All right, we're doing our quarterly assessment number 1. This is the retake review. All right, let's go ahead and let's jump in. Problem number 1, simplify the expression. All right, a lot of you guys are going to want to combine like terms right now, and you cannot. You cannot do that until you get rid of the parentheses. Remember, to get rid of the parentheses, we distribute. Since there's nothing in front of this, I'm going to put a 1 right there to help my brain. All right? So we got 1 times 6x is just 6x, and 1 times negative 1 is just negative 1. The second group, we're going to multiply by a negative 1. Now, this does change things, right? That minus makes this a negative 1. So negative 1 times x is a negative 1x, and negative 1 times negative 4 is a positive 4. Now we can combine like terms. All right, we've got a positive 6x and a negative 1x. 6 minus 1 is 5, and we still just have x. Okay? Make sure that you don't start messing with exponents when you're combining like terms. And we've got a negative 1 and a positive 4, which we add up and get a positive 3. So 5x plus 3 is my answer. Okay? All right, let's look at problem number 2. Here we go. All right, problem number 2. Simplify the expression. Okay, same thing as number 1. You can't combine like terms yet. You got to get rid of the parentheses, guys. So for anything without a number in the front, use a 1. This last one is going to be a negative 1. All right, 1 times 2x is 2x. 1 times negative 3 is a negative 3. 1 times 2x squared is still a positive 2x squared. And 1 times negative 3x is still a negative 3x. But in this last group, we're multiplying by a negative. Negative 1 times 3x squared is a negative 3x squared. Okay? And a negative 1 times a negative 5 is a positive 5. Finish by combining like terms. So I like to do my x squareds first. We got a 2x squared and a negative 3x squared. Well, 2 minus 3 is negative 1. And we still have x squared, right? Don't mess with exponents when you're combining like terms. Next, I've got positive 2x and a negative 3x. Okay, so again, 2 minus 3, still a negative 1, but this time we just have x's. And finally, our constants, negative 3 plus 5, is just going to be a positive 2. Stop here. You cannot go further because none of these are like terms. You did all you could, you're done. Okay, problem 3, here we go. In problem 3, it says, what is the value of f of 2? You guys need to remember that when you have a number like this, whatever's in here is an x, and whatever you find is going to be a y. So I like to imagine it like they gave you half of a point. They gave you the x value of a point, and you have to figure out what goes here. Okay? So what point on this line would be 2 comma something? Okay, well, that would be right here. Right? What's the coordinate of this point? That would be 2 comma, in this case, 1. All right, so the number that we were missing, it's just that number 1. That's all you got to do, right? They're going to give you an x value. Your job is to find the y value that goes with it. All right, problem number 4. It's actually pretty similar. Here. They gave you f of 0 this time. They want to know what is f of 0. Again, the number in the parentheses is an x, so you're looking for a y. Okay, well, in a mapping, left column is x, right column is y. So they're telling you x is 0, well, what is y? Well, if x is 0, y is supposed to be 1. So in this case, it ends up also being a 1. Just a coincidence. Okay, remember, guys, x is in the parentheses, and the y is the answer that you're going to be giving. Problem 5. In problem 5, we're talking about the perimeter of a rectangle, and you're given 2 sides. So definitely always start out these problems by drawing a picture. All right, we've got a 2x plus 3 We've got an x minus 1. A lot of students add these up and call it a day, and they're wrong. Because if you're doing perimeter, you need all the sides. Okay? Technically, you could remember this formula, 2w plus 2l, and plug in these items and distribute and combine like terms. But I feel like a safer way, a way that a lot of us feel more comfortable with, guys, just label this rectangle. We know this is also 2x plus 3. This also has to be x plus 1. And we can just add these up. So 2x plus 3 plus x minus 1 plus 2x plus 3 plus x minus 1. So let's combine our like terms. We've got 2x and x, and also another 2x and another x. If it helps you to remember there's a 1 on these x's, that might be good to write down. And so we've got 2 plus 1 plus 2 plus 1. Guys, this is going to be 6x when we combine all of those. And then we add up these numbers. Well, 3 minus 1 is 2, plus 3 is 5, minus 1 is 4. So it's going to be 6x plus 4. And that's all we got to do. Label all of our sides, add them all up, and we're done, right? That's perimeter. Flip this over. Let's look at problem 6. So 6 and 7, hopefully you guys notice we've got the same graph here. Problem 6, we're finding the domain and range, and problem 7, we're finding the range. So in problem 6, let's not forget domain means x. What are all the x's? And range means y. All right. So something that I always make my students do is I make them draw a boundary around their graph. So then we can say, okay, all the x's go from here to here. And we can see that, okay, at this point over here, x has still not gone left or right. It's on the axis still, so x is still 0. And over here on the right, x is 5. Right, so from left to right, we went from 0 to 5. And my x, it's like we're literally saying x is in between 0 and 5. Okay? Don't forget, though, you need inequalities. Just a quick reminder. Closed circles get this inequality. Open circles get this inequality. So in this case, since I don't have any of these guys, we're going to do a less than or equal to symbol for both. And that is my domain. All right, those are all my x's. Let's go ahead, let's do the same thing for our range, right? We're going to look at our y's now. Okay, again, I think it's helpful. I'm going to draw a box around my values here. Okay, and since it's our range, we're looking from the lowest to the highest. So here's the lowest, and here's the highest. So all the y's go from here to here. The lowest point is here when y is 10. The highest point is up here when y is 30. So all the y's go from 10 to 30, right? All the y's are between 10 and 30. Again, since we don't have any open circles on our graph, we're going to use less than or equal to symbols for both. And that is our range. Okay, let's move on to problem number 8. Problem number 8, we're going to simplify this expression with these radicals, these square roots. And we want to add them up. Now, guys, we cannot add them up because these numbers are supposed to be matching. Otherwise, it's not allowed. So what we got to do is we're going to go ahead and we're going to do factor trees. Now, if I do a tree for this 3, it's going to be 1 and 3. Not helpful. Remember, when we have prime numbers, there's really nothing we can do. So let's focus on this 27. All right, well, I know 27 is 9 times 3, and 3 is prime, so let's work on the 9. All right, I know 9 is another 3 times 3. So really, since I already was given this 5, I've got 3 times 3 times 3 in there. Okay, don't forget we're looking for pairs of numbers. A saying that we say in my class is you got to have a date to leave the house. So I've got a pair of 3s, so those get to leave, and this 3 has to stay inside. Now the numbers that get brought out get multiplied. So I've got 15 square root of 3. Careful, careful. Don't forget that you actually had this here in the front earlier, right? This is a problem we were trying to add. So we've got 2 squared of 3. We're trying to add 15. But now we're happy because our numbers inside are matching. So we go ahead and add these up. So how many square roots of 3 did I have? Well, I had 2 square roots of 3, and then I added 15 square roots of 3, so my final answer is 17 square roots of 3. Just a quick way to check your answer. Remember, decimal answers will not be accepted on a problem like this. Go ahead and type in the original problem, which is 2 square root of 3 plus 5 square root of 27. And you're going to get a crazy decimal, which is that. Now we're going to type in what we simplified it to. So we're going to say 17 square root of 3. What do we get? All right. They're ugly decimals, but they match, right? That's a great indicator that you probably did this problem correctly. All right, problem number 9. Here we go. All right, problem number 9. If you're given f of x equals negative 4x squared plus 15, what is f of negative 3? Remember we talked about this earlier? If you have a number inside of here, it's an x value. So we're going to plug it in. Right? Think about it, guys. If I had f of x equals negative 4x squared plus 15, and then I'm looking at f of negative 3, well, didn't this x turn into a negative 3? Same thing's going to happen over here on the right side. Instead of having x, what am I going to put in there? I'm going to put negative 3. All right, x has become this negative 3. On this, I would go ahead and just type this in my calculator just like that. And I'm getting negative 4 parentheses. Guys, if you don't use parentheses, you're going to get this wrong. Got to use parentheses when you're substituting. Got this squared plus 15. And we do get negative 21. That's it. That's the answer that we're looking for. Okay? All right. Now we're going to do the last one, problem 10. Okay, in problem 10, it says, which situation is best modeled by the expression 25 minus x? I'm actually going to forget the problem here for a second. I'm going to focus on each individual one of these, okay? All right, A. How would I write this in algebra? The total video games after George places X more video games on a shelf with 25 video games. So it's saying he had 25 and he's putting X more. So we're adding X to the 25 that was already there. Let's look at B. The miles left after Sarah has driven X miles of a 25-mile trip. So she's driving 25 miles and she's already driven X. So how much is left means we're going to use a minus sign here, right? This expression will tell someone how much is left in this trip, right? 25 minus however miles she already drove. And we could stop here, but we're going to do the rest for practice. Okay, problem C. The amount left on the bill after Amelia paid $25 of an X dollar lunch that she shared with Ariel. So in this case, the bigger price is this X. The X was the total price. Amelia paid her 25. Do you see how this is backwards from what we wanted, right? The bigger one would be X minus the 25. And last but not least, the total number of baseball cards when Jorge has 25 boxes full of X baseball cards each. Guys, the word each tells us to multiply, right? So 25 times X. That's not what we wanted. Okay, so in this case, the best answer would have been B. Okay, remember guys, your retest is extraordinarily similar to this. If you can do these 10 problems, you should be okay to do the 10 problems on the retest. Make sure that you get that done before the deadline. Good luck.